Okay, so this is our second day of 1.1. So where we left off, let's actually just recap our first page. Okay, so the first page in your interactive notebook that we already did is 1.1. We had this on our first page. Then when you flip over the first page, you should have example 1 on the back. Okay? All right, and then we started the collinear and linear. The coplanar and the non-coplanar. And we wrote down all those definitions, okay, last week. So if you missed any of those definitions, you're going to go back and you're going to watch the first video. And then did we have time to talk about the postulates? Okay, so maybe some of us need to finish writing down the postulates. Maybe some of us need to glue in the yellow piece of paper or the pink piece of paper. And then remember, this is the page where some of you were able to put this full page in on your notebook, but some of us, this was the front page, this was the back page. Okay, so that's just going to depend on what size your notebook is. Okay, so some of you have the postulates on the back page. Right, so the first postulate, 1-1-1, says through any 2 points, there is exactly one line. And what that means is if you see 2 points, even if there's not a line drawn in between them, so even if you can't physically see the line drawn, you can always draw a line in between them. Then the second postulate in 1.1 is through any 3 non-collinear points, there's exactly one plane containing them. So again, as long as those 3 points are non-collinear, which, Robert, what does it mean if they're non-collinear? Good. Okay, so if the 3 points are not on the same line, there is a plane between them, even if we can't see that plane. So those are 2 important things that we have to know to answer the questions in our foldable above. And then the last one is if 2 points lie in a plane, then the line containing those 2 points also lies in the plane. Okay, so let's open up our foldable now. So for some of you that may be on the previous page. And the first thing that it asks us are points F, A, and Y coplanar or non-coplanar. Right, now you can see that I've already written in there that it is coplanar. Were we able to do that one together yet or no? Okay, so the points F, A, and Y, they are coplanar. And then we have something that says explain. So we have to talk about why it's coplanar. So if you look at F, A, and Y, you really want to ask yourself, are they collinear or are they non-collinear? Okay, so do F, A, and Y, do they lie on the same line or do they not lie on the same line? Alex, D, what do you think? Are those collinear or are those not collinear? No. If they're not collinear, we just talked about how any 3 points, there exists a plane. So the reason why these are coplanar is because through any 3 non-collinear points, there's one plane containing them. So even though we can't see that plane physically with its edges, it still exists. Okay, so remember from last week we talked about planes do not have any thickness. Okay, so even though we're representing them with these edges on paper, they are infinite. Okay, I want you to go ahead and I want you to read the next 3 questions in there. You don't have to do the explain part, but will you go ahead and just answer those 3 questions? They're going to ask you things like, is it coplanar, non-coplanar, collinear, non-collinear? Okay, and make sure you guys are spelling your answers right. The words are right in front of you. Coplanar or non-coplanar. They straight up ask you. Okay, so let's look at the next one. It says, are F and Y collinear or non-collinear? Tyler, what do you think for that one? Okay, collinear. Do you know why you're thinking that? Does it help if I tell you you're right? Okay, so he's right. They are collinear. Anybody think about why those have to be collinear? Yeah. Exactly. So because there's 2 points, there's a line in between any 2 points. Okay, so through any 2 points, there is going to be one line. Hey, so Andrew and I were just talking, and he said it doesn't matter what 2 points they give you, they're already going to be collinear, right? Yep, so as long as it's just 2 points that they give you, it'll always be collinear. The only time you have to worry about them not being collinear is if there are more than 2 points. So if you had 3 points and one of those 3 points was not on a line, that's when it would be non-collinear. Okay, so the next one says points F, R, and B, are they coplanar or non-coplanar? Okay, and I said that they were non-coplanar. So if you look at F, R, and B, F, R, and B all lie on the same line, which means that they're collinear. Remember, in our postulate, that they have to be non-collinear in order to make a plane. Okay, so if all of the points are on the same line, they are non-coplanar. So F, R, and B must be non-collinear in order to make a plane. And the next one is directly related to this. So F, R, and B, are they collinear or non-collinear? We just talked about how F, R, and B are collinear. And that's because they lie on the same line. So going back to the one above that, if you're trying to find 3 points that are coplanar, it could be any 3 points as long as they do not all lie on the same line. So F, R, and E, those are going to be coplanar. Okay? B, R, and Y, those are going to be coplanar. The only ones you have to worry about are ones on the same line. And then when you're done with that, you can flip to your next page. Okay, so you either have page 2 all on one page or on both pages. Now you are going to your third page. And then before we even glue that one down, okay, so this is the last one that you guys got. Did some of you fold this yet? Okay, good. So you fold it, and then you're just going to cut and throw away this one part. Okay, so what I want you to do is I want you to open this up. And then whatever is written on the outside, you're going to see that's going to help you answer the questions on the inside. So when you look at the inside, it says 2 lines intersect at blank. I want you to fill in the blank. 2 planes intersect at blank. I want you to fill in the blank. A plane and a line intersect at blank. And again, you can find those answers where? Where can you find the answers to the blanks? On the front cover. Okay, so Cameron, 2 lines are going to intersect where? At a point. Okay, so on your fill in the blank, you can just write a point. I wrote exactly 1 point. And then that does have a special postulate that goes with it. It's not imperative that you know what the number is, as long as you know that it is a postulate. And then you can see on the picture, I just made a point where they intersected. 2 planes are going to intersect at exactly 1 line. And then I highlighted that line where they intersect. So you can either use a highlighter, you can circle it if you just have a pencil. And then that also is a special postulate in your book, and that postulate is 1-1-5. And then I just put a little note on there for you, so you'll notice that some lines are solid, other lines are dashed. If you see a dashed line, that's to show the hidden parts of the figure, which is really just the lines that are behind other lines. Okay, so if you were looking at it straight on, that's why some of them are dashed. And then the last one is a plane and a line intersect at exactly 1 point. So the line is going to intersect a plane, but it does not lie in the plane. So you can intersect a plane without the line being in a plane. And the best way to think about that last one is a pencil going through a piece of paper, right? So this is what we're modeling. I'll show you around there too. Okay, so the pencil is the line, and then here's our plane, okay, is the piece of paper. So the one point that it intersects in is going to be the point where the pencil meets it. Okay, if you think of two planes, you can think of like two note cards cutting each other in half. So now that we know that information, I want you to fill in the right side of your chart. So on the right side of their chart, they're just asking you to find points of intersection. And I also want you to make sure that you label those accordingly with what we talked about last week. Okay, so for the first one, Grace, we know that two lines intersect where or at what? A point. Okay, so the only possible answer for this one should be a point. Ryan, what point did you put for this one, the first one? M. And then the way that you're going to label that, you can either just put M, so just the letter M, or point M. Do not put a dot. Okay, it's only going to be point M or M. Okay, now the next one is two planes. Okay, and Alex D, two planes intersect at what? A line. Okay, so your answer for the second one has to be a line. And Alex, what did you put for that one? Perfect. Now, this line actually has many, many different names. So you could call it XZ. That's also what I chose to call it. Again, the important part is your labeling. So check yours, maybe even check your elbow partners, that they have not just a segment, but you have to have the two arrows on each end in order for that to be counted 100% correct. Okay, so make sure you have the line symbol. So XZ, that line can also be called ZX, XR, RX, RZ, or ZR. Okay, so any two of those points, and it doesn't matter the order, those are all names for that line. The points that you use, notice how those occur in both planes. Okay, you couldn't use this one because Y is not in this plane. S is not in this plane. Okay, and then for the last one, a plane and a line intersect at one point. Now, when you're doing the intersection of HEF, remember, in order to make a plane, you need how many points? You need 3, okay, and they have to be non-collinear. So you can pick any 3 of these points, but the plane that contains HEF is going to extend in all directions, which means it is going to include G. So the plane HEF, what's another name for a plane HEF? You could do, you could do EHG. You could do what else? FHG would be fine. Okay, so as long as there are 3 non-collinear points, that's going to be a plane. So this plane and this line intersect at one point, which is going to be G. Okay, and then if you need a minute to glue that down, you can glue that down. And then if you want, you can also like cut these into strips. If you like it better not cut into strips, that is fine too. I will leave that up to you as your personal choice. Okay, and then if any of you need help joining Google Classroom, I'm giving you time to work on this. I can come around and help you with that because I did post an announcement too. So remember, this is what I showed you last week. So these problems, but maybe you couldn't finish them all because we didn't do the last foldable. That's fine. So tonight, your homework is going to be to finish any problems that you didn't from here. You're going to have a points, lines, and planes chart, which I'm going to give you time to do today. And then a real-world intersection chart. Okay, and then whatever you don't finish of those in class will be homework. Okay, and then you guys also need your crossword out. And then on the back of your crossword, you can label numbers 1 through 10. Okay, because the next thing we're going to do is review our syllabus. And then after we review our syllabus, I will give you those charts. Okay, I'll show you the charts real quick. So 1 and 2. The first thing I'm going to show you is number 2 because this is the first one that you'll want to complete when you have time. So you'll be given this chart. Notice it has some blanks. 2 lines intersect at a point. So that's something you could fill in right away. 2 planes intersect at a line. A plane and a line intersect at a point. Okay, so that would be the first thing I would write down. Then I'm also going to give you this sheet of 6 boxes. What you have to do is cut out those 6 boxes and then paste them in the correct box on the chart. Okay, so something shows 2 lines intersecting, 2 of them show 2 planes, and then the last one is a plane and a line. Okay, and that's something that you should be able to get done in class today. Something you should be able to start that you may have to finish at home is going to be this chart. Okay, so this chart, you're going to have a definition, an illustration, and then a naming. Again, you will be given a sheet where you will cut out your possible answers, and then you will paste your possible answers in the correct boxes. Okay, and then that's something that I will check tomorrow. Okay, so before you go, I will give you those 4 sheets.